This time we will discuss Theorem 2 of complex numbers. Theorem 2 states that if x sub 1 plus j y sub 1 equals x sub 2 plus j y sub 2, then x sub 1 is equal to x sub 2 and y sub 1 equals y sub 2. Theorem 2 of complex numbers simply states that if two complex numbers are equal, then it follows that their real parts are equal and their imaginary parts are equal as well. We simply cancel j in equating the imaginary parts because this becomes jy sub 1 equals jy sub 2, and dividing both sides by j, we have y sub 1 is equals to y sub 2. Alright, so this is the theorem 2 of complex numbers, and for this theorem we will solve some examples. Okay, so the first example is solve for x and y in the following equations. So the first equation is x plus jy squared equals 2 plus j4. Okay, so the first step is expanding the left side, and then the second step is equating the real parts of the left side and the real part of the right side, the imaginary part of the left side and the imaginary part of the right side. Okay, so expanding this, we have, you recall that a plus b squared is equal to a squared plus 2ab plus b squared. So we have x squared plus 2jy plus jy squared, or j squared y squared. We distribute the exponent. The right side is equal to 2 plus j4. Alright. Recall that j is square root of negative 1, so j squared is equal to negative 1. So we have x squared plus 2, this is 2 times jxy, so jxy. Okay, so x squared plus 2jxy, this is negative 1, y squared equals 2 plus j4. So this becomes x squared minus y squared plus 2jxy equals 2 plus j4. We now equate the real part with another real part and the imaginary part to the other imaginary part. So we have x squared minus y squared. Using theorem 2, this is equivalent to 2 because this is the real part having no imaginary number, and the other one is 2jxy equals j4. As I've said, we can simply cancel j, so this becomes 2xy equals 4, or we can say that y is equal to 4 over 2x. 4 over 2x, and that means y is equal to 2 over x. So we can have this as our equation 2, which we will substitute later on. So this one becomes we can use this as our equation 1, where we substitute our equation 2. So y is equal to 2 over x, so this becomes x squared minus 2 over x squared equals to 2. Okay, multiplying both sides by x squared, we have x squared squared minus, so this is 2 squared times 2 squared over x squared. So multiplying by x squared, both sides we have 4, and x squared cancels, equals to x squared. Okay, so let's proceed. Okay, allow me to start at the very top. Let's just copy x squared minus, let's transpose this to the other side, minus 2x squared minus 4 equals 0. Okay, so we have we can see that this is a quadratic equation. This forms a quadratic equation. Let's say, let's substitute, let u be equal to x squared. We have u squared minus 2u minus 4 equals 0. And taking the quadratic equation of this quadratic equation, taking the value of u, we have u equals negative b plus or minus square root of b squared minus 4ac over 2a, or you can simply use your calculators. Using your calculator, you get a value of u which is equal to 3.24. And since u is equal to x squared equal to 3.24, then square root of x squared, square root of 3.24, x yields a value of 1.8. So this is the value for x. And substituting this value to y, we have y is equal to 2 over x, 2 over 1.8, which is equal to 1.11. So our y is equal to 1.11. So for the equation x plus jy squared equals 2 plus j4, the value for x using theorem 2 of complex numbers is 1.8, and the value for y is equal to 1.11. Okay? Right? We using theorem 2 of complex numbers, we solve now our second example. That is example B, which is 2x plus j3y squared minus 6 minus j12 equals 0. Okay, so same process. We expand this first, and you recall that a plus b squared is equal to a squared plus 2ab plus b squared. So this becomes 2 squared, or this becomes 2x squared plus 2ab, so 2 times 3, 6 times 2, 12 x jxy plus j3y squared. j3y squared, we can transpose this to the other side, so this becomes x 6 plus j12. So this becomes 4x squared plus 12 jxy, and j squared is negative 1, so this becomes negative 3 squared is 9, y squared equals 6 plus j12. Okay, so the real part is 4x squared minus 9y squared. And the imaginary part is the one having the j, which is the middle term. Here, the real part is 6 and the imaginary part is 12. So, Theorem 2 of complex numbers states that we can equate the real parts and we can also equate the imaginary parts together. So, 4x squared minus 9y squared equals 6. And the imaginary parts together, we have 12xy equals 12. As I've said, we can simply cancel the j. So dividing everything by 12x, y becomes 12 over 12x. Y becomes simply 1 over x. So this is our equation 2. And we use this equation later on. We substitute it to our equation 1. Okay, so here we have our equation 1. And we simply substitute, since we cannot no longer simplify this, we substitute y equals 1 over x to this equation. So we have 4x squared minus 9 times 1 over x squared equals 6. So what we have is 4x squared minus 9 over x squared equals 6. And we multiply everything by x squared so as to cancel x squared here. So we have 4x to the power of 4, or we have 4x squared x to the power of 4 minus 9, x squared cancels, and we have 6x squared. Okay. So that we can simplify the equation, we let x squared be equal to u. So we have now 4u squared. Transpose this to the other side so as to form a quadratic equation. 6u minus 9 equals 0. And solving for u using your calculators, quadratic equation, we have u equals 2.43 approximately, and since u is equal to x squared, which is 2.43, we take the square root of both sides. We have x now equals the square root of 2.43, which is approximately 1.558. Okay, so this is now our x value. Okay, making the substitution for y is equal to, remember, y equals 1 over x. So therefore y is equal to 1 over 1.558. Y therefore is equal to 0.642. So for this equation, the values of x and y are 1.558 and 0.642 respectively. Our third example for Theorem 2 of complex numbers is C cosine squared x plus j sine y cosine of y minus sine squared x equals 0.866 plus j 0.5. Okay, cosine squared x plus j sine y cosine y minus sine squared x equals 0.866 plus j 0.5. So here again, Theorem 2 of complex numbers states that if two complex numbers are equal, we can equate their real parts and as well as their imaginary parts together. So we have cosine squared x minus sine squared x, so this is the real part, and equate it to the real part of the other side, which is 0.866. And we can also equate later on the imaginary parts. Okay, but we'll start here. We have, this is a equivalent to double angle of cosine theta, so cosine 2x equals 0.866. And we have, therefore, 2x equals arc cosine of 0.866. That is, 2x is equal to 30. Using your calculators for this is 30 degrees divided by 2, x is equal to 15 degrees. Now for the other one, we have this one, sine y cosine y, and it's equivalent to 0.5. We can simply cancel the j's for the both sides, and sine y cosine y has an identity. If you remember that 2 sine a cosine a is equal to sine of 2a, double angle of sine. So therefore, sine y cosine y is equal to sine of 2y divided by 2. Okay, since this does not have 2 here, so divided by 2 equals 0.5. Multiplying 2 to both sides, we can cancel the 2 here. We have sine of 2y is equal to 1. And 2y is equal to arc sine of 1. We recall that arc sine of 1 is 90 degrees because at the angle 90 degrees, remember, sine starts at 0, 0, and at 90 degrees or pi, the value of our sine is 1, and then it goes down again, and so 2y is equal to 90 degrees. Therefore, y is equal to 90 degrees divided by 2, which is equal to 45 degrees. So for this equation, the values of our x and our y are 15 degrees and 45 degrees respectively. Theorem 3 of complex numbers is very easy and self-explanatory. It states that if you multiply two complex numbers and the result is 0, then either the multiplicand or the multiplier is 0, or both are 0. So that is, if you have x sub 1 plus j y sub 1 times x sub 2 plus j y sub 2, if this is equal to 0, then either x sub 1 plus j y sub 1 is equal to 0, or x sub 2 plus j y sub 2 is equal to 0, or both. And so you can use this principle in order to solve the value of the x's and the y's. Okay, so that ends our discussion on theorems on complex numbers. Thank you and God bless.